This week we're looking at predictive analytics, and in particular we're going to look at classification and regression. And so let's start with the iris dataset, which is one of the classic machine learning examples. So I'm going to go ahead and make a new notebook for this, Python 3 kernel. And then let's start with our import. So we're going to need the same stuff that we've been using and also a few things from Scikit, which is a data science exploration package. And we're going to use linear regression out of that. So import pandas as PD and import numpy as NP and import, let's go matplotlib.pyplot as PLT for graphing. And then we're going to use some Seaborn examples. So let's go Seaborn as SNS. And then we're going to need two things from the Scikit package, scikit-learn. So first thing is from sklearn dot model selection. We need to import train test split. So that's going to allow us to take a data set and split it into a set of training data and a set of test data. And then we're going to build our model using only the training data so that when we test it on the test data, we can basically expect that it's going to work the same as it will on new cases that we received that we didn't train on. So the goal here is not to get the highest accuracy on the training data. The goal is to get the highest accuracy on new cases that you haven't seen yet. And so in order to understand how well our model works, we want to test it only on cases that we didn't train with. So this train test split is going to make it easy for us to do that. And then the other thing we're going to import is from sklearn.linear model, we're going to import the linear regression class. And this is just one of many different types of models that you can learn using the sklearn package. So let's go ahead and execute that. And everything loaded correctly. So let's go ahead and add another cell. And then, as I said, I'm going to use the iris data, which is a JSON file. So let's do iris data is pd.readJSON. And then the name is iris.json. And then let's look at what we have. And so this was in the previous week's downloads if you need a copy of it from somewhere. What do we have? We have sepal length, sepal width, petal length, petal width. And these are the independent variables. So basically input to the learning model, the things that we're going to use to learn the output. So the dependent variable, the thing we're trying to learn based on the values of the independent variables, is this species here. So basically this can be viewed as a classification task where, given a set of inputs or independent variables, we're trying to predict what classification or dependent variable we're looking at for the case. Now, linear regression models, what they do is basically they fit straight line curves, straight lines on a data set. And so we're going to see that more in a minute. But the problem here when you're trying to build a classifier is that linear regressions go from numbers to numbers. So you can create some line function based on these inputs. And then what you're going to get when you run this through a line equation is a numeric value. But what we actually want here is a classification. So how do we bridge that gap? Well, one way of representing the classification is as a set of Boolean values. So basically, instead of having one column here for classification that has Setosa and versicolor and virginica as three classifications, we can have three Boolean columns, and one is basically, is the thing a Setosa, yes or no? Is the thing versicolor, yes or no? And is the thing a virginica, yes or no? So Boolean values can be represented as 0 and 1 values, and all of a sudden, now we have a way of mapping numeric values here to three separate numeric values here for the classification. Now, you can do this by hand pretty easily by saying something like, if I take, let me go ahead and go iris data, and if I apply a function like lambda of x, if, actually, let me do this. So I'm going to pull out the species column, and then each value in the species column, I'm going to return 1 if x is equal Setosa, else 0. So this is going to return 1 if the species is Setosa and 0 otherwise. And if I execute that, what I get back is a series of 0 and 1 values. And then I can do the same kind of thing here. So let's go ahead and if I do iris data species, make this be versicolor. So there are the versicolors, and they're all in the middle here. And then let's do that one more time for virginica, like so. And so the virginicas are at the end. So here are three separate sets of values that I can add to my original data frame. So I can say like iris data square bracket, call that is Setosa, is equal to that, and then we'll do iris data is versicolor is equal to that, and iris data is virginica is equal to that. Oop. Okay, and then if we add all three columns, we can look at our iris data. And so what we get is our species column and then three additional Boolean columns for whether it's a Setosa, whether it's a versicolor, or whether it's virginica. So that's the hard way of doing it. This is such a common thing to do, where you're taking a category and turning it into a set of Boolean columns so that you can either use these as independent variables to predict an outcome or dependent variables to be predicted. That's such a common thing to do that there's a function built into pandas that will allow you to do it. So I'm going to go ahead and make another cell here. And if we do iris data, actually pd.getDummies, actually no, it is iris data.getDummies, and we execute that. No, it was pd.getDummies. So pd.getDummies and then iris data. So what this does is it goes through all of the columns in iris data and it looks for ones that have categorical values in them. And for any categorical values, there's like the species column has a category in it. What it does is it adds new columns. So species Setosa, which is Boolean, and then species versicolor, which is Boolean, and species virginica, which is Boolean. So basically, these three columns are exactly the same as the is Setosa, is versicolor, and is virginica that I added manually. But I do that all in one operation, so that's convenient. So now that we know how to do that, let me go ahead and I'm going to delete this column here. I'm sorry, delete that cell. And then I'm going to set dummies equal to this. And then I'm going to execute reread my iris data without any new columns. Then I'm just going to execute my get dummies and then look at our data set. So here's the actual data set that we're going to be processing now. And you'll see that when you use get dummies, what it actually does is replaces the original categorical column with these Boolean values instead.